Hi everyone, welcome back. I've made 5 videos on two-step equations. Can't call them all 2 steps because I've added to them. But normally in year 8 and 9 we get to this certain level of questions, maybe depending on what class you're in, you might go further on the equations and get more complicated. Want to make some videos where just revision, you can watch the night before a test, or you could watch just to make sure you're okay with all the concepts if they're put together into one. So here we go. 6 examples squashed on the one whiteboard. Let's see how quickly, but not too fast, that I can explain them. The goal of solving equations, if you watch the previous videos, is get the x by itself. So we want the equation to say the answer is. And how do we get an equation to say the answer is? By it saying x equal. We can talk that to making the x a subject. It just says the answer is. So I need to get rid of that 3, and I also need to get rid of that 1. I can choose to get rid of the 3 first, or I could choose to get rid of the 1 first. If I get rid of the 3 first, there's a multiplication between the 3 and the x, and the opposites to both sides. The opposite of timesing by 3 means I'm going to divide by 3. And if I divide by 3 here, I need to divide by 3 there, and I need to divide by 3 there, and you start introducing fractions. And one of the biggest topics that people muck up on is fractions. Just reading the exam report a couple of days ago from the Year 12 Methods High Level exam here in Western Australia. It actually talks about one of the questions, the weakness that people had with fractions. It just happens over and over again. So beware fractions as much as you can. So let's get rid of the plus 1 first because it's easier to move. It's not doing multiplication and division. So how do I get rid of the plus 1? I minus 1 from this side to balance up the scales. If I minus 1 from this side, it's 1 lighter. If it was kilograms, it would be 1 kilogram lighter. And so that would go up. To balance it up, we're going to minus 1 from the other side. So if I minus 1 from the other side, I like to write it up here so that you don't have to write another line of working out. Let's have a look at what we've got. So now we've got 3x, 1 take 1 is 0, so I don't have to write plus 0. And then 4 take 1 is 3. And basically now it tells you the answer that you could have looked at in the first place. But remember, it's the method that matters, not whether. You can look at the simple question and get the answer. So try to be patient with it and take your time on the method. Even if the method seems awkward and uncomfortable to start with, it gets easier after a little while. So now I've got a times by 3 and the opposites to both sides. What's the opposite of times by 3? I divide this side by 3, balance up the scales. I divide this side by 3, and 3 into 3 goes 1x, and 3 into 3 goes 1. So the answer is 1. So really we're just talking about the answer is 1. So there's the first one. Now the process is explained there. Let's go for this one. If I add 1 to this side, I add 1 to that side. I could have divided by 5, but it will introduce fractions, and too many people struggle with fractions or make silly mistakes with them or really don't understand fractions. So what have I got now? This minus 1 plus 1 mucks some people up. You can do it in reverse, it's 1 take 1. So if I write that as 1 take 1, everyone will be okay and say it's 0. So the purpose of writing the opposite is to get rid of something. So the opposites of both sides is so I can get rid of that minus 1. So if you don't want to think about the negatives too much, we're getting rid of a minus 1 by going plus 1. So you're left with 5x equals 4. Now there's a multiplier between there, just like the previous question. The opposites, divide by 5 this side, divide by 5 that side. 5 into 5 goes once. I don't have to write the 1 because the answer is x equals 4/5. Now that's one that would be harder to guess. Some people can. I've tested many classes on it verbally and people can work it out because they're very sharp at their mental arithmetic. This one's got an extra step. This is what happens in tests. This looks different. This looks different. This looks different, and so does that one. So let's have a look at it. There's a multiply between the 4 and the bracket, just like we had a multiply between the 5 and the x. So the rule is anything, 2 things written next to each other, have a multiply in between, except if we write a number like 17, it's not a multiplication between the 1 and the 7. So I use the eyebrows. This means 4 times everything in the bracket. So we've got a 4 times x is a 4x, and then the rest of it is the 4 times 3. The eyebrows, especially as it gets more complicated, makes a big difference in organising people. So the 4 3s would be 12. Now we're back to, by expanding the bracket, the question looks like those. And again, I made it so it wasn't nice numbers. So if I get rid of a 12, if I subtract 12 from this side, I subtract 12 from that side, Now I'm left with 12, take 12 is gone. So I'm left with 4x and taking away more than what you had, and we've got a -1. So you could go up and down the thermometer and work out 11 take 12. But you can watch that on other videos on negative numbers. Between the 4 and the x's are times. If I divide this side by 4, I divide that side by 4, and I've got an answer of 4 into 4 goes 1, so that's a 1x, and the answer is -1/4. That would be hard to guess. Go to this one. Looks the same, but it's got this part here, which is a divide by 2. I could just go multiply by 2, multiply by 2, multiply by 2, and some people prefer that, and that would be one possibility. This one's a +3, I could go -3, -3. For the moment, I'm going to go multiply to show you what happens, because this is handy when it gets to harder questions. So if I multiply this one by 2, I multiply that one by 2, and I multiply that one by 2. Don't forget, there are 3 things here. We talk about terms, there's 3 terms here, and there's an equals in between there. So I've made the 2 look like it's a numerator or a top, so your brain can cancel out the 2 with the 2. And here's the question, how many times does 2 go into 2 when it's once? I don't have to write the 1x. Now I can go 3 2s are 6, and I can go 5 2s are 10. Then the last step, I can go subtract 6, subtract 6. If I want to get rid of the +6, I subtract 6, and then I'm left with x equals 4. Could have done the question again. I could have just gone x on 2 plus 3 equals 5. And if I would have gone subtract 3 first of all, do it to both sides, and I'm left with x on 2 equals 2. How do I get rid of a divide by 2? If I times this side by 2, I make it look like a numerator. So this is a numerator and the denominator at top and the bottom. I multiply this side by 2. I get the same answer as before. 2 into 2 is 1, which is just an x. I don't have to write the 1x. So it's not that the x is 1, it's a 1x, 1 of x. 2 2s are 4, and you've got the same answer as before. So it's your choice which way, all the way through these. On this one, what a lot of students do wrong, they go +3 to both sides there, and the moment they do that, they're going to get the incorrect answer. And the reason they're getting the incorrect answer is that fraction bar means that there's a bracket around this. We don't have to write the bracket, but it is there the whole time. So every time you're doing a fraction, there is I like to do this, bracket around the top and a bracket around the bottom. So obviously no need to put a bracket around 5. So you can't go +3 because the bracket there, the vinculum, the fraction bar, is controlling that -3, so you can't just pluck it out. So here we go, if I want to get rid of divide by 5, the opposite of divide by 5, the opposites to both sides. If I multiply this side by 5, I multiply that side by 5. Let's have a look what happened. 5 into 5 goes once. So we've got 1 of the x, and we've got 1 of the 3. And it's got a minus. So 5 into 5, all I do is cross them out. I think of them as gone. Just be careful if you think of them as gone, that they're actually 1. So it's not 0, because that would make our whole question up. So I cross them off, and we're left with just the x minus 3, so I didn't complicate it by putting the brackets in. Just cross them off, and you've got a 5. Now you've got a really easy question. How do I get rid of a -3? I add 3 to both sides, because it's the opposites to both sides. People still have trouble with this. It's really 3 take 3 is 0, so I'm just left with an x, and that's an 8. So the question tells us the answer. I could go back and check, put the 8 in instead of the x. You have 8 take the 3 is 5, and when we divide the 5 by the 5, I end up with 1. So you can check your answers are right. 6 is just a little bit of a trick, not much, but it's amazing how many people it throws off. A couple of things I've done, I've left this as a 1x. So we've got lots of x's here. When we want the question to say x equals, we just want x. We don't want x and more x's around the place. We want it just to say x. So 4x take 1x is 3x. And if you haven't learnt collecting like terms, as long as the x's are the same, with the same powers, I've had 4 of them, and I subtracted 1 of them, I end up with 3 of them. So the x's don't disappear. It's really the numbers at the front. 4 take 1 is 3. Then I've got plus the 3. So all I did was add in an extra step to make it more confusing. Now it's like doing one of these. So fairly quickly on this. Opposite of +3, opposites to both sides and no rush. If I subtract 3 from this side, I subtract 3 from that side. And a lot of teachers like you to write that on a separate line. That's okay, just do it till you get the hang of it. It works. 3 take 3 is gone, so I've got left with 3x. So we had something complicated, that becomes just a 3x, and then this becomes just a 3x by itself without that 3 there. 8 take 3 is 5. Now a little bit on fractions I did on purpose. Between the 3 and the x's are times. The opposite of times by 3 is divide by 3. If I do it to one side, I do it to the other. Balance the scales up, opposites on both sides. And I'm left with this answer of 5 1/3. And again, because of this topic of fractions, I know that so many people have trouble with fractions. Let's have a look what happens. How many times does 3 go into 5? I could do this. 1, 2, 3, 4, 5. If you're okay with this and you know it's 1 2/3, don't need to watch the end. 3 into that goes once. 3 into that goes once. And it's got a remainder of 2. So primary school, some people will teach with an R of 2. So there's our remainder of 2. And if we're talking about thirds to start with, we're talking about thirds to finish with. Depending on your teacher, a lot of teachers will accept 5 on 3, or you can change it to 1 2/3. Usually in year 7, 8 and 9, teachers will insist on you changing it into 1 2/3. Some people like to write as a decimal. Decimals can be inaccurate. Because 1 2/3, 2/3 is 0.6 repeater, and you watch so many people with decimals write that as 1.6. Then you're asking for the teacher to take marks off that you knew how to do the equation, but you didn't know how to get the decimals correct at the end. So be careful if you're writing it as decimals. Fractions are very easily what we call exact. There's no approximating, whereas the decimals, people can make mistakes when they're rounding off and doing all sorts of things with them. Thank you.